Okay. As I go along this, I'm always going to hit one girl and two boys. So I'm always going to have a 0.6 times a 0.4 times a 0.4. Right? The other one will have a 0.4 times a 0.4 times a 0.6. It's the same thing. 2 0.4s multiplied and a 0.6. So no matter what I get, I'm going to get 0.4 squared times 0.6. Because I have two boys, two successes, and one girl, one failure. Good? I have to say that. I can't go the other way. So no matter what, I'm going to get this. And this number is going to be the same as that number, and the same as that number, right? They both have 2.4s multiplied by 0.6. That's where this whole p to the x times q to the number of failures. P to the number of successes times q to the number of failures you have. This part, the n choose x part, the n choose x part comes from how many ways, how many of these outcomes end up here, right? Because if I wanted to know how, probably having exactly two boys, I would find these three things and add them. But since they're exactly the same, I could just multiply by 3. Do you guys understand what I'm saying? This is the same as that, this is the same as that. I can either calculate each of these and add them, but since they're the same, I can just calculate one of them and multiply by 3, because instead of adding 2 plus 2 plus 2, I can just take 2 times 3. Everybody understand that idea? Because it's the same thing. So I'm just going to, that's where this, how many ways are there of having 3 items and picking 2 of them to be boys? 3 choose 2, which is 3. So that's where that whole binomial comes from. Right? The little p to the x multiplied by the little q to the n minus x. That's a probability of ending up right here. And then you multiply by n choose x to tell you how many of them there are. Because you'd have to add that to itself that many times. Everybody totally good with that?
Yeah.
Now the second part of this thing, of your problem, which is probability x is 0. The beauty of x is 0, when all of them are successes or all of them are failures, it's super simple. We don't even need the binomial thing for that. The binomial only helps us when we need to figure out how many branches end up with that possibility. If we, this one, whoops, sorry. This one is if they're all boys. That's really easy. We don't even need binomial for that. All boys, boy and boy and boy, 0.4 times 0.4 times 0.4. Simple. That's when we have to mix and match that we have to go to this binomial. Because we don't know where the boy is, or the girl is, you know what I'm saying? Or if it's girl, 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 again, that's really easy because there's only one way of doing that. Girl times girl times girl, right? 0.6 times 0.6 times 0.6. It's when we have this mixed up, some boys and some girls, we have to do the binomial because we don't know how many, we can't just say girl, girl, boy, because it could be girl, boy, girl, or it could be boy, girl, girl, and we have to like figure out how many of them there are and add them all up. But the all or the none, super easy. You just take the probability of none, of not one, and raise it to the power of how many you have. So that's the simplest. So our issue here is, whoops, not here, here is just that. It's probably x is 0 is going to equal 0.6, sorry, what's probably a failure? 0.68 to the 8th power, because there's 8 of them. Now you might have done 8 choose 0. How many ways can I have 8 items and pick none of them? Just one way. And say, okay, not picking any, done. Right? Not you, 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 and not you. That's it. That's it. You understand what I'm saying? So that would be 1. And then 0.32 to the 0 power. Any number to the 0 power is just 1, called hook of identity. So then we just get this. So what do you guys get for that?
0.0457.
0,
457.
right. And the one above was 0.2835. And
Yeah.
then the probability X was 1 was
0.1721.
1721. Great, so this one is going to be adding them all up, right? At least less than 3. Less than 3 means 0 or 1 or 2. Ors we
And
add. Right, so then we would add those up, because any one of those would be a way of qualifying it. If I had zero people had a college degree, then that would be less than 3. If 1 had a college degree, that would be less than 3. If 2 have a college degree, that's less than 3. So you add those up, and you get, kind of not being efficient amount of time here, are we? 3, 1, 1.
5, 1, and 3.
Perfect. What about at least one has a college degree? What would that be?
Just the point, x equals 0 and then x equals 1.
That's less than 1 or less. Is it saying at 1 or less?
Oh, at least 1.
So either I have at least one sibling, or I have
X equals 0, and then the
I
x
either have at least one sibling, or I have none.
Yeah.
Those are complements. So at least one means 1 or more. Does everybody understand that? So you can find the probability of 1, probability of 2, probability of 3, 4, 5, 6, 7, 8, and add all those up. Yes?
Yeah, or can you just do 8, choose 0, and then whatever you get, subtract that number?
Exactly.
Perfect, butter.
Because we've got let's look at this. We can have here's x and the probability of x. So when x is 0, 1, 2, 3, 4, 5, 6, 7, and 8, we can either find all of these and add them up, or since we know if we add them all together, they have to equal 1 or 100%. Right, we want the purple stuff. Everybody, you understand what I'm saying? We want the probability of 1 or more. Find all the purple ones and add them. Or we can take the blue one and subtract from 1, because we know that the blue plus the purple has to add up to 1 or 100%. All the probabilities have to add up to 100%. So we could just do 1 minus probability that x is 0. In other words, 1 minus 0.0457. So you guys get 0.9543. Good?
Yeah.
And then these ones we did earlier, last class, right? The mean is NP, variance is NPQ. Good? Okay. Great. Did we do this one already too?
No, no.
Do it now. Do it quickly. It is warm. I'm gonna open the door.
Thank you.
Should I pause this? I should pause this.
How far the number is
Yeah,
from
I
the mean?
can.
Come on.
Number of standard deviations of values above or below the mean.
There
Right.
you go.
So you figure out how far a value is away from the mean and you divide it by a standard deviation. Okay, so the first one, my z-score for 560 is going to be 560 minus 690 divided by my standard deviation. What do you guys get for that one?
Negative 1.354.
Great. For the other one, the other z-score, z2, is going to be,
0.9375.
hold on a second.
Oh, my bad.
0.9375.
Yeah.
Great, that's it. That's the last part. Now, find the probability that x is between those two values. That x is between 560 and 780. First, you have to find the z-scores. We've already done that. And then once you find the z-scores, you just do normal CDF. Right, so maybe a little picture might help us. I like pictures. So here's my middle. 780's over here somewhere. And 560's over here somewhere. and we want the area between them, probability. Remember, the area is probability. So I found the z-score for this one. This z-score is negative 1.354. This z-score is 0.9375, right?
Mhm. Then you plug them in.
So these are x values. These are z-scores. And to find the area between those, you're going to do normal CDF. Everybody remember that one? Yep. Of the left z-score, negative 1.354, comma, the right one. And you got what?
Where was number
7,
two?
3, yeah.
Seven what?
Bars.
5.
Anyone?
9.
Bueller?
0.7374.
7374. Good?
Yeah.
Everybody else get that?
Yeah, I got 7.9, but we might have rounded.
I
different.
rounded mine.
Yeah, that's why
Yeah.
then. Okay.
Okay, 7374, 7379, something like that.
So on the exam, we're drawing and labeling?
No,
Okay,
I'm just doing this so you guys understand where these come from.
okay.
If you get lost, you might want to draw a picture. Drawing a picture will help you.
Okay, and then
Are
what
you
do
on
you
Calvin
find?
sitting over there?
What did you find normal CDF again?
Is that why
Second
he's
bar.
he's
Second
over
bar,
here?
okay.
Yeah.
So would you,
Okay.
so that's isn't
Alright,
that the
thank you.
standard deviation somewhere?
Yeah, 0.9.
Didn't realize it was gonna throw you off that much.
No, no, no. Well, and I'm all for it. Rams is over here. She should be over there.
I just wanted to try out this perspective.
That's good.
I'm all
Oh,
there.
Yeah, you
Yeah.
guys are
Scoring
over,
stuff.
over there, over here. Everybody's in a different spot. Almost everybody.
0.1354 greater than 0.937, and you just do it like this.
No, what threw me off was like you're all bundled up, so I can't really see who you are.
And what?
You're all bundled up, so I can't.
Oh.
Yeah.
All right.
And then, I mean, one of the security guys was like, "You recognize me?" And they both had sunglasses on and shaved heads. And I'm like, "Sunglasses on and shaved head? How am I supposed to recognize it?" All right. Anyway. All right. So what does this probability mean in words in the context of the problem, context of entrees?
About 74% of lunches fall between $5.60 and $7.80.
Good. That's one way of putting it. What's another way of putting it?
A random lunch chosen would be between,
Wait, so,
We'll have a probability of.
yeah, has a 74% chance of being between $5.60 and $7.80.
Exactly. So those are the two ways of saying it. Either the percent of population, percent of them will be there, or the probability of picking one and having it be there will be that percentage. Okay. Rats. The first one is 1 rat, right? Or 36 rats. Is that the first one? Oh, okay, so yeah, this one, do 1 rat first. So we're gonna skip 8, we're gonna go to 9. And let's do the second part first.
So if you just go down and push play, and it should be
Oh, we're just one.
7.379.
so I'm just gonna do that later.
I was like, you know how to help you.
Yeah.
Right, yeah.
So if you're gonna random select 1 rat, what's probably their weight of that one, its weight is less than 12 grams. Just 1 rat. We're gonna do part 2 first. Just 1 rat. What's probably take out the word mean. 1 rat. What's probably its weight is less than 112 grams. I gotta change that. So the word mean should not be there on the second one. Its weight is less than 112 grams. Yes, it is. Thank you. I should turn that off. Or did you guys find it already? No? All right. All right, we'll take a quick look here. All right, so this is my review slide from 6.3. Remember, if we want to know, for given an x value, and you want to know the area, the probability, first you take the x value, convert it to the z-score, right? You change it to the z-score by doing your z-score. How far is it from the mean, about how many standard deviations is that divided by standard deviation, right, convert to a z-score. And then we use normal CDF to figure out the area between this and say, if I wanted to know this one and above, then I put in from this z-score to there. If I wanted to know below, I put in this z-score to there. What's the z-score way over that way?
Negative 99999.
Yep, what's the z-score way over there?
Positive 99999.
Right, so put in the left z-score, comma the right z-score. That'll give you the area.
Is that part of this question, or did you
No.
didn't ask, okay, I'm
That,
gonna
well,
say
this
wait.
is how you do this question.
But you didn't ask
You
area,
chose
do you
this.
finish it off?
16?
I'm sorry?
Oh, you did wait, like, you normally say that, and this
I
normally
did ask, I
says-
asked for the probability. Probability is area.
Okay.
So your problem was this one here. So you need to find the z-score first. That is gonna be, he's 112 minus 115 divided by the standard deviation. And you guys got negative
0.1875.
1875.
What number it is?
Draw a little picture.
That was
Right.
also the,
Negative 0.1875. You want the
Six
area
standard deviation.
less
what
than
is this
it.
number
This
So
is
it's
the
on the
mean
left?
means.
about? Okay,
So you're gonna
so
do
the mean,
Yeah.
normal CDF
you still in it? Okay, I'm just confused.
of my left z-score, which is what?
think this was
Negative 999.
Okay, okay.
Comma negative 0.81875.
working.
And you guys are gonna get 44256. 44226.
What?
No,
Yeah, just 4256.
425. Sorry. 42.
Why did
I'm
I not
thinking,
get
like,
that?
what's going on?
Okay.
Yeah, I don't know why your calculator's not giving you that. Yours
I
is-
didn't get that either.
Yeah, I didn't get that either.
I got 0.2667.
So you got 0.49 over here,
Yeah, I
but
must have done
I'm like when I did it, this is I rounded
So
up to
second
40.
bars, you guys are using that?
No.
Oh, because you did negative 0.999.
Ah.
So here's the thing. If you are somebody who accidentally, did anybody get, what'd you get
Two.
before that?
Something, 2.4. But that's, I haven't changed it.
2 and some change.
If you
Because
got,
they have
That's
it.
if you got 0.2667, anybody get that? If you did, you have a habit of instead of doing negative 999 or positive 999, of doing 0.99999.
Oh.
Which is the same thing as just doing 1.
1, okay.
Is 1 unusual?
No.
No. Is 1 old? No. Pick your grandmother's age, 87. And then that will solve that issue. Because no one does 0.87, you know what I'm saying?
Ah, okay.
You would just do, so just pick your grandmother's age.
Got it.
His is
82.
giving him like 49 for some reason.
It should be 4256.
Yeah, that's what I got
Okay,
too.
so,
That was my problem.
I'm like trying to walk him through it, and still giving him 49. I'm like,
Because you have to
Like,
meet-
you should not have
you have
a
to
decimal
six
there.
deviations.
So it's just
Standard deviation should be 1.
negative 999.
If you have a fancy calculator, leave your mean at 0 and your standard deviation at 1.
oh, you have a
Okay.
fancy one, that's why. Okay, there you go.
You
I was
have a
like, bro,
fancy
I don't
one,
know how to
that's-
help you right
I
now.
was like so confused, I was like, I thought we were supposed
Alright,
to
now,
This has zero?
we're going to do it again.
So,
Only,
so,
we're going to
No, I don't know
use,
where you are.
that's,
we're going to do part 1 now. So now we have, if we have 36 rats, what's probably their mean weight of those 36 rats is less than 112.
This is the one.
oh, that's what we do.
That's what the one.
It's pretty much the same thing.
That's what this is.
So you have that.
Yeah, so you did that. That's what, okay, cool. I forgot we did it. She's making us do it backwards. That's why I didn't-
Okay, so I wrote this in the wrong.
Yeah, that goes there. That's- But you, yeah.
That was like 2 days.
Or she's ever need to
This
follow.
is for
16, 17.
Yes,
Just
the
gonna
fine
restart.
36.
I don't know, I might go get some food and stay again. I'm sitting there solid.
Hey guys, what kind of problem is this?
Oh wait, 'cause this is like where we're at right now.
How's this
Yeah,
different from the
okay,
previous
so
one?
Actually,
How's this different from the second part?
They give you N.
They give you n, which means that you don't have 1 rat, you have how many rats?
36.
36.
36, that changes things. What's the probability that I randomly pick a Steph Curry game and he scored 50 points that game. It's unlikely, but is it 0?
No.
So maybe like 5% chance, 4% chance, something like that. What's probably I pick 36 Steph Curry games randomly, and the average of those games is 50 points.
Pretty not good.
Impossible. Do you guys understand what I'm saying? Or let's pick something simpler. Like, what's probability that I pick it and that I pick a game and he averages 40 or more points, 45 or more points. That could happen, right? That's a little more likely. Maybe 10, 15% chance.
Yeah.
But if I pick 36 of his games and average that, the average of that game is going to be 45 points or more? No. Why? Because when if you take a bunch of them and you take the average of them, then the high ones are going to balance out by some low ones, and you're going to get stuff that's right around here by the time you average them all in. Right? This one will average out that one, and you're going to get something here. This one will average out that one. You're going to get stuff that's like right around in the middle if you average a bunch of them. Or who doesn't know sports? Who's like not familiar with basketball? Okay, so tell me something you're familiar with that makes sense to you.
Food.
What was that? It was puppies.
Cats.
Puppies. Okay, so you go with puppies too, right?
You know about puppies, right?
He doesn't know anything about puppies.
Like, you know what puppies are, right?
Okay,
How many times
so say you there's a bunch of puppies in the yard, and there are different types of puppies. Let's probably pick a puppy and say the average weight of all these puppies is like 7 pounds. Okay? But some puppies will be a little smaller and like a teacup, and they might be like 1.5 pounds. And some puppies might be a little heavier, and they might be like 11 or 12 pounds, like a lab or something like that, maybe a little bigger, right? What's the probability that you pick a puppy, but the average of these puppies, their weights is 7 pounds? What's the probability you pick a puppy and it weighs 11 pounds? It could happen. You see what I'm saying? Mm-hmm. But if I pick 36 of these puppies and I average their weights, I'm not going to get an average of 11 pounds. They're not all going to be like big dogs. Does that make more sense? Okay. All right. Okay. That wasn't such a great option. Yeah. Okay. But all right.
That's the
So
formula.
let's get back to this one. So instead, because it's not going to vary that much for the mean, if I pick a bunch of them, the ones on the ends are going to cancel each other out, and they're going to end up being kind of close to the middle. Then, if I pick 36 of these, my standard deviation is going to be not this. It's going to be this, right? It's going to be small. So when we figure out the z-score, we can't use the regular s. We've got to use, or the regular sigma. We've got to use. Everybody know what we're doing here?
Yeah, you have to use the smaller
Yeah.
scaled version of it.
Because we're talking about their weight, not one puppy, not one rat, but the mean weight of 36 rats. So what's our symbol for mean weight? For average? Sample mean?
X bar.
X bar. We're talking about a sample, right? The sample mean. So instead of using sigma, we're going to use sigma X bar. Do you guys remember that? Mm-hmm. What's that? What's that called? What starts with a C? Anyone? Say it louder.
Central limit.
Central limit theorem. So sigma X bar is equal to sigma over square root of n. So, give you guys a minute to figure this out, sort this out. All right, so again, we want to find an area from an x value. So first we have to find the z-score. So the z-score is gonna be 112 minus my mean, 115, divided by sigma x bar. Sigma x bar. So what's, maybe I'll write it like this.
Yeah, no, I didn't finish it.
X minus mu. Or actually it's x bar minus mu. Alright, so what's my sigma x bar?
1.6.
Yeah, it's gonna be 16 over square root of 36. Which you said was-
2.67.
2.67.
2.67?
Yeah.
Great. So here we're gonna do 112 minus 115 over 2.67. Everybody do it. If you didn't do it already, do it now. What'd you get, Zach?
1.1235, or 1.1236, excuse me.
Okay, 124. So you're gonna get negative 1.124. Yeah.
On the test, I can't remember, are you gonna need us to show the formula z equals x bar minus mu over?
No.
Okay,
I would like this.
okay.
So give me that at least. That'd be good. All right, and then the last thing you want to do is, so now you have your z-score. Yeah.
Is this all going online?
Oh, sorry. This. Yeah, but we're working on.
Oh, I'm here. I just.
Okay.
So.
Yeah, I'm videotaping it too.
She's doing like another thing after this, pretty sure. Where she's like going over stuff.
So right now we're working on number 9. So what's the last thing we do, guys?
Plug in your numbers.
So yeah, I found the z-score. I need to find the area. So I'm gonna do. If I want to find the area, I do
You can brush that.
normal CDF of what's my left z-score?
0.99.
Negative
Yeah.
999, comma what?
Negative 0.1875.
1.125.
Oh yeah. Dang it.
Where'd you get that 0.875?
I was looking at the wrong one. I was
Okay.
looking at the one from below it.
And what'd you guys get?
0.1305.
1305.
Right.
Okay. You guys are super quiet, and there's not a lot of confidence looking. Like you guys are not looking super confident.
Not at all.
Trying to grasp it. Just implant it in my brain. Could do it with
Okay.
steps.
So why don't you guys work on the next one?
Like 10?
Number 10. Work on 10. All right. Central limit theorem is the same as. Is everybody good with the rat? The first one single rat.
Right. Yeah.
Central limit theorem is exactly the same as that. The only difference is when you're talking about a mean, you have an n, like Ramsey said, you have an n. You're talking about a mean of them. Then instead of using the sigma 16, you use 16 over square root of n. Everything else is exactly the same. Right? It's still the same stuff. 112 minus 115 divided by something. The only difference is the something is no longer 16, it's 16 divided by square root of n. That's the only difference. All right, you get your z-score, you draw your picture, you shade, and you do normal CDF to find that area. So that's the only thing that's different. Are people confused because it's been too long since we've done this stuff?
Yeah.
It's been a real long time, yeah.
So this is exactly the same as the problem we did a second ago with the entrees, right?
With this?
The probability that,
Oh,
no,
you're talking about this one?
yeah, so, the one we just did. The rats is the same as the entrees. All right, so it's okay. So yeah, this stuff is just that 40%, the 20% from the beginning and the 20% from the second exam that you guys haven't seen in so long that you're all like, what? All right, so What's the probability that I pick her randomly and she works part-time? What's probably she works part-time?
40%.
Great. What's probably she works part-time?
40%.
What's probably he works part-time?
40%.
What's probably he works part-time?
To the fourth
What's
power.
probably she does and she does and he does and he does? And we
4, 2, 3.
Multiply or
Multiply.
divide, or
yeah,
no?
well, yeah, but like,
Yeah.
yeah, but I mean, or it's gotta be for one thing. So it's gonna be 160% chance,
Yeah, that's ludicrous, you're right.
right? And we multiply. So it's the first student and the second student. So it's the probability of part-time, of work, and work, and work, and work. Sounds like a song, isn't it? Work and work.
Oh.
My fingers to the bone.
And
Yeah.
work.
All right, so this is going to be 0.42 times 0.42
Oh, yeah, we did.
times 0.42 times 0.42. In other words, 0.42 to the fourth power.
Is
You
it?
have that?
Yes.
That's it?
That's it.
That's really
Okay.
What is that?
0.0311.
0.311.
Oh, we still got.
You still got it right.
See, we did it
Oh,
the
sorry,
4
no.
choose 4, but we still got it the right answer.
You could do it. You could use binomial on that.
Yeah, that's what we did.
It's just
Way
overkill.
longer.
You could totally do that.
Yeah, it would
Right?
took a lot more time.
Right. Because this is a simple version, you don't need to go to the complicated version, but you could totally do that. All right, is this likely or unlikely? Why is it unlikely? Less than 5%. Everybody on board? Great. Yes.
On the exam or final, can we leave it as a decimal or do you want us to put it in?
Decimal's fine. What is probability? Yeah, so the general rule is if you're given a decimal, your answer should be in a decimal. If you're given a fraction, your answer is usually in a fraction. That doesn't, but I'm going to pretty last on that part. What's probably that none of them works part-time? Everybody take 15 seconds and find that. None of them. So she doesn't, and she doesn't, and she doesn't, and he doesn't.
One minus 986. That's the only.
I know, me too.
Don't go into auto mode on it. Think about it.
No, she's messed with that calculator.
All right.
Let's
Yeah, I
see.
guess I did quite.
What's the probability she does not work part-time? 58%. What's probably she does not work part-time?
58%.
What's probably she does not work part-time? What's probably he doesn't work part-time?
58.
What's probably she doesn't and she doesn't and she doesn't and he doesn't?
58 to the 4th power.
58 to the fourth power.
So it's
It's really bad.
it's
The alls and the nuns.
all
Alls and the nuns are easy.
Mm-hmm.
What was this again? What's this again?
1-1-1-3-1.
1, 1, 3, 2?
Yeah.
Or 2?
2.
Okay. Great. Now, you guys might be saying, well, what about that 1 minus? So then, let me ask you a second question to make you, those guys happy. What's the probability that at least 1, at least 1
Right.
is where you start subtracting things?
Yeah.
Yeah.
Works part-time.
And then that would leave that.
Okay? Alls and nuns are simple. It's the at least 1 that's the complement. At least 1 means 1 or more. So I'll give you guys 10 seconds. Figure that one out. Figure out what the complement is of at least 1. Either I have at least 1 puppies, or I have at least 1 donut, or I have no donuts.
That's that.
Incidentally, I took all that food to our, we had kind of a department meeting on Friday, and they were like, oh my gosh, thanks. And I was like, yeah, I came with a pizza and like brownies and cookies and cookies and cookies and chips.
like, this was really thoughtful of you.
It was very thoughtful of you guys.
I have mad respect for whoever brought oranges. I was
Oh,
like,
yeah.
there you go.
Oranges were good. Alright, so at least one is what?
1 minus that number, which is
1 minus what? 1 minus all or 1 minus none?
none.
None.
So it's
Probability of none.
0.8868.
So it's
Yeah.
1 minus 0.1132, 8868. Just like Zach said. Okay, good. Do this one. Quickly.
I don't know this one right yet.
I got a ludicrous number on this, but maybe
Wait, where is this?
12. Skip 11.
Security code, 4 digits. Wasn't it like the exclamation mark thing?
I don't know. It is.
26 letters in the alphabet. So
I mean, this one's order doesn't matter.
I got like
I think you're right, 'cause there'd be that
So
many
order
ways.
Order doesn't matter.
Because there's that many ways to do,
You have 10 total.
to do a 4-digit. Yeah,
Yeah.
that makes
So
sense.
that would be like
so ridiculous, right?
9 times, what is
No,
letters?
because order doesn't matter.
Ah, it's the same thing, bro. There's 26.
It's N, right? NC.
So Carly asked me that. I was like, shit, I don't know.
Okay, guys.
Let's do it.
So this is, what kind of problem is this one?
Cumulative?
It's a how many problem. Do you guys see that difference there?
Yeah.
So, how many? So, let's see, so, fundamental accounting principle, you figure out, what do I have here? I've got, how many decisions am I making?
2 several? Oh, wait, 9?
Well, look at this, how many things am I picking? 6. How many options for my first choice?
9?
No.
10.
10. It's a digit. How many digits are there? 10.
And
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. See where it says 0 through 9? How many options for my second one?
10.
Next one?
10.
Next one?
10.
How about letters? How many options there?
26.
26. And 26. What do I do with these numbers?
Multiply all of
Multiply.
them. Yeah.
Got it?
I keep not counting zeros and stuff.
Good? Alright, do problem 11 right above it. So it's counting. So then, can you reuse items or not reuse items?
Can't read.
can
Can't reuse items. So it's going to be a permutation or combination. Everybody on board with that part?
Yeah.
So it's going to be permutation or combination. What's the difference? Permutations are the normal one. Right? You just figure out how many in this one, how many in that one, how many in that one, multiply them. Combinations, one of my other students said, combinations are like chaos. Because it's C, combination, chaos, because you have to divide things out and it's a fraction, and fractions are chaos. So combinations are the ones where it's chaos, you gotta divide stuff out. Which one is this one? Permutation, because it's in a fixed order matters. So you guys understand that?
Yeah.
Alright, so the first one we're gonna look at is order matters. Oh, I don't have it in here. Seriously? Oh, that's messed up. Okay, that's all right, we'll make it up. So we have 5 people. You have 7 men, 5 women, and you need to do a committee. Each assigned a task. And this is number 11. A. Alright, so order matters. One of my students said the way she likes to think about it is if you pick people and you throw them into a bin and they're all just kind of moving around anywhere in that bin, order doesn't matter. If you pick people and you put them in specific spots, you do the dishes, you man the door, you sweep, then order matters. So that's kind of how she wrapped her head around it. Okay, so this one, order matters. So we're gonna do, how many people we're picking?
5.
5. How many options for the first spot?
12,
Next spot?
11,
Next one?
10,
Next one?
9,
Next one?
8.
Done. Why are there 12? Because,
12 people total.
yep, equals 12 people. Let's take a look at B. Now, order doesn't matter. Does everybody kind of see that? They all do the same thing?
Yeah.
So this one is the combination, the chaotic one, because you have a fraction. So it's going to be 12, choose 5. So it's going to be the same 5 spots. Right, 12 times 11 times 10 times 9 times 8. Only now, we have to divide out the duplicates. Because it doesn't matter whether I picked, if I picked Alejandra first, or second, or third, or fourth. It's all, doesn't matter which order I picked everybody in. Divide out all the duplicates. So this is going to be divided by 5 times 4 times 3 times 2 times 1. So 1 for everyone above, kind of, 1 for every spot. So how many ways are there of arranging 5 items? 5 factorial. Right, 5 items, 5 factorial. How many ways are there arranging 4 items? 4 factorial. Good? All right, let's take a quick break. Before we do the last one. Draw a card. This is my
This is my
vanishing deck. Draw a
favorite
card.
part.
Have you seen it before?
No, but this class, this is my favorite part of this class is your magic tricks you throw out.
What's the card? Ace of Spades? Show it to everybody. Everyone see that? Hooray. Ace of Spades? All right, put it back in upside down. Upside down?
Sure, yeah.
Okay.
I'm confused.
She's gonna.
She got real cards, bro.
There it is. Go ahead and draw it.
Oh my gosh.
Wow, it's an ace of spades.
Wait, can I?
Loaded deck.
I don't. I have no idea what just happened.
Can you move it back?
Yeah, can you do
Yeah.
it over here?
Sunblock.
You guys want to do back there?
No, I'm just saying wherever.
Okay.
She wants to do it.
All
So.
right. Draw a card. What is it? Look at it. You gotta look at it. What is it?
5 of spades.
Obviously, so turn around, put it back in upside down. All right.
What is going on?
All right, it's my
Magic,
deck.
dude.
Well, she never did cards in it. That's crazy.
Yeah, you have to share. I mean, I don't understand. Otherwise, we're rich.
It's magic.
It's
I
magic.
told you. I
Magician
can tell you
never-
what I have to tell you
Witchcraft.
afterwards.
It's witchcraft.
Bro, if Martin was here, he would know
Yeah,
exactly what
dude,
she
I'm
did.
just smart already.
I don't even get this.
All right, back to this. So the last one, is that not my best trick of all my tricks?
That was pretty good.
Yeah,
That
it
was
is.
pretty Like I said, I don't know how good it is though, because if Martin was here, he might still be able to find out what you were doing. Like every magic trick, he's been like, "Oh, well, watch me do it too," and he knows, he
Right,
figures
right.
the math out.
Well,
just
the
by
They
math
went to the
ones,
same
math
class.
ones totally. The magic ones are just magic.
just magic. Okay,
Yeah.
all right.
It's like
Yeah.
Flex.
little fairy
Was
dust.
it? No, it's on. It's in. Thank you. All right, so let's do the last one. Let's do C. Probability that none of the, oh wait, no. The members have the same responsibilities, but you have to have 2 men and 3 women. So does order matter?
Yeah.
Same responsibilities?
No.
No, order doesn't matter. But I need to have 2 men, exactly 2 men. I need to have 3 women. So yeah, it's still 5 total. But I have to have 2 men and 3 women. So what do we do with this one? So I need to have 2 men out of how many men?
7.
7. 2 out of 7 men. And I have to have
3 out of 5 women.
3 out of 5 women.
So 7 choose 2 plus. 5 choose 3.
Okay, you're on the right track.
Okay.
7 choose 2, and
Time.
I have to have. Do I have to have? Do I have to have either 2 men or 3 women, or do I have to have both of them?
Well,
Both of them. So it's an and. You guys see? And we multiply. So, like Amber said, it's 7 choose 2 men. Right? This is men. So this is the number of ways for the men. And then we have 5 choose 3. That's the number of ways of picking women. And I have to have both of them. I have to have 2 men and 3 women. So we multiply those. So kind of think of it like this too. Like if this is my number of ways of picking 2 men, everybody kind of understand that? I could pick, here's 7 men. I could pick these 2, or those 2, or those 2, or those 2, or those 2. I have all these different ways of picking 2 men from those 7. Then I need to pick 3 women. So from every one of those, I pick 3 women. Here's my different ways of picking 3 women. So say there's 10 ways of picking 3 women. Every one of these has 10 different ways. Do you guys see what I'm saying? So in terms of the tree, I have, how many groups of 10 do I have? 1 for every one of these. So it's the number of these times the number of things in that. It's just like a regular tree. Except my tree goes 4. You guys remember that? That tree? You guys look at me like I'm crazy.
and the choose is the way to bypass drawing the tree, right? Like the 5 choose 2.
Yeah,
Okay.
you don't have to. 4.4. There it is. Right? Remember? If I have 2 pants and then I pick 3 shirts, right? So number of ways of picking pants, from every one of those I have shirts. So I have how many groups of 3? 2 of them. If I had 20 pairs of pants, it would be 20 times 3. Do you guys see what I'm saying? So you take the number of ways there are picking 3 men, all these ways, and then from every one of those, so actually why don't you guys go and find these? How many ways is, what's 7 choose 2? 21? And then what's 5 choose 3? 10. So for every one of those ways of picking 2 men, I have 10 ways of picking the women. So I pick these 2 men times 10 ways of picking the women. I take these 2 men times 10 ways of picking the women, right? So I have 21 times 10 ways of picking 2 men and 3 women. Right? Okay. All right, so why don't you guys take a look at number 13. Probability. It's been a while.
Got me.
Isn't
there.
that given?
That is.
All right, what's probability that someone likes broccoli?
51.
51?
Yeah.
5100%?
51%.
51 over 100,
0.5.
or 0.51. What's probability that they're a man or a child?
60.
Right, so you're going to take your 38 plus your 22 out of 100, so 60 over 100. Or you could put 0.61 if you wanted to as well, or 0.6, or 0.60, sorry, what am I saying? What about a person who is a child or likes broccoli?
63.
Right, so children, there are 22 children. There are 51 people who like broccoli, but these 10 are being double counted. They're getting counted in this group and that group, so you have to subtract out 10. So 22 plus 51 minus 10 out of 100, 63 over 100. Everybody on board with that?
Yeah. And then
Because Yeah.
I'm sorry, but for
Because-
these ones, since it's out of 100, it's just like the percentage. But if it was out of 80, you'd want the real percentage,
Yeah.
right? Okay.
No, you can just put over 80, that's fine.
Oh, okay. Okay.
I don't need the decimal, just leave it as a fraction.
Okay.
All right, how about they dislike broccoli and they're a man? Dislike broccoli and is a man. So, okay, so everybody knows that and means multiply, right?
Yeah.
Mm-hmm.
But it's dependent. So you could do and means multiply. So you'd have to do broccoli. Broccoli is, or dislikes broccoli, so it's 49 over 100. But then you'd have to do is a man given they dislike broccoli. So that's 21. Given they dislike broccoli would be only, it would be 21 out of 49. Man given they dislike broccoli, 21 out of 49. And then these guys cancel out, and you get 21 over 100. The easier way to do that with a table is just to look and say, which are the ones that are men who also dislike broccoli?
Yeah.
21 out of everybody, out of 100. Everybody on board?
Yeah.
So this is for you guys who feel like you have to multiply, because and means multiply. It means you take the first one, but then it has to be given the first one's happened, because this is dependent, right? It's a lot simpler just to say, oh, men who dislike broccoli. If you're a man and you dislike broccoli, there's 21 of you. 21 out of 100. Done. Good?
Yep.
But I thought I'd clarify this was where people kind of get screwed up, is it, when they get into that and means multiply. It does. For the dependent, it means given. And then I think, what was your next one?
Given.
Oh yeah, so
Yeah.
given. Likes broccoli, given.
Given's a woman.
Mhm. Probability of broccoli, given they're a woman. So here, what's the probability that they're a woman?
Oh, no.
What's probability they're a woman?
4.4.
100%. We've given you that. You know it's a woman. So for this one, I'm gonna, here, let me do this. This one, you know they're a woman. You know it's not one of these. So this is going to be probability of broccoli given woman is, broccoli is 24 out of 40. Someone see where we got those? 24 out of 40. And again, if you try to figure out what people don't have trouble finding the 24. They have trouble figuring out to divide by. What do you divide by? Looks like this is kind of like dividing by the number of women. Given is what you divide by. Think of it like a division sign. Broccoli over women. Okay. And the last one is, what's the last one? The last one is, are broccoli and women independent?
Yeah.
No.
Yes.
So independent, we learned from chapter 11. Is this on?
Yeah. You're good.
Broccoli, so independent is the same thing as,
Probability of E given A is equal to probability of E.
right, so probability of broccoli given women is the same thing as probability of just broccoli itself. The ratios, proportions are equal. Do you guys remember that one, our test for independence in chapter 11? Proportions are equal. So we're looking at these ratios. The ratio of this to this should equal the same ratio of that as that to that. So what are these ones? These ones are 51 and 100. So is 24 over 40 equal to 51 over 100? Question mark? Are those equal? No. And if you're not sure, just put them in your calculator and see what decimals you get. So that means that they are not independent. Because remember, independent means equal. Independent, they would be equal. Right? H naught equals, independent is the equals. Are they mutually exclusive? Do you guys remember mutually exclusive?
That's no, because you don't have to be a girl and like broccoli. And you don't have to be
Can you
broccoli.
be a girl and like broccoli?
Yeah.
Yes, of course.
So mutual independent means, mutual exclusive, sorry. Mutual exclusive means I'm excluding you, you're excluding me, we're both deciding to exclude each other. We have nothing in common.
Oh, okay.
Can you be a girl and like broccoli at the same time?
Yes.
Yeah, so then you're not mutual exclusive.
Okay.
You can be both.
Can't do.
Yeah, good we're going over this, right?
Is that gonna be on the test?
Could be.
Like, should I write it down?
Nothing.
You should know it.
All right.
It's in 2
okay.
days.
So yes, write it down.
I don't know. I haven't looked at the test in a while. Okay. Let's look at the marbles. Marbles.
Mine are gone.
Draw a tree.
Okay.
Game.
All right. So, tree. What are my options? Red, blue, green. Let's probably draw a red one. 2 out of 11. Why 11? Add it up there, little marbles. Okay, how about blue? 4 out of 11 and green? Perfect. Now, am I putting the marble back or not?
No.
No. Here's a hint. Say I have a bunch of pens. Where are my pens? I don't have them. Say I have a bunch of pens. And I have them. But yeah. Great. So I've got 3 purple, 3 red, 2 orange. And someone takes a pen. Here, have a pen. And she also takes a pen. Are they going to take the same pen?
No.
No. Do you guys see what I'm saying?
Yeah.
So when someone takes a pen and they keep a pen because they get a pen, and another person, they both get a pen, they're not going to get the same pen. They're going to want their own pen. Do you guys kind of follow on that? Mm-hmm. Okay, so that will be true on the test as well. Okay. So this is without replacement. So it means for my second draw, what could I draw? Red, blue, or green? Right? Oops.
Oh, I should have put them in order.
You need to have your answers at the end of these things. Right? The destination should be green. That should be at the end of it. Next one, blue. That should be at the end of it. The probabilities go along the way on the branches. Everybody kind of follow? All right, so what's the probability of red? If I drew a red, what's the probability the next one's red?
1 out of 10.
1 out of 10, because now I only have 1 red marble left, and I only have 10 marbles left. Blue, 4 out of 10. And green, 5 out of 10, because I still have 4 blue and 5 green. Those haven't changed. All right, how about here? If I drew a blue first, how many reds do I have left? 2 out of 10. And how about blue? 3 out of 10. And green? 5 out of 10. Good. What if I drew a green one first? Red would be 2 out of 10. Blue would be 4 out of 10. Great. And green would be 4 out of 10 as well. All right. Good? Great. Now, what's probably the first draw is either green or red. So green or red, ors we add, so 2 11ths and 5 11ths, so 7 chances out of 11. Good with that? Okay, how about blue then red? So then kind of means and, but in that order. So I draw a blue one, and then I draw a red one. So it means I went this path right here. Get it? Make it bigger. Blue, then red, that path. What's probably of that? 4 out of 11 times 2 out of
10.
10. Right? Blue and then also red. And we multiply. So 8 out of 110, I'm fine with that. If you want to reduce it, that's great, you don't have to. Okay, so far?
Yeah.
That last one is going to be probability. Probability, I have a green on second, given blue first. So this means, what's the probability I drew a blue one first? Nope.
What?
What's the probability I drew a blue one first?
Green.
100%. I'm given that.
Right.
Given blue on first. Okay. So that means for sure I am standing here. Given blue on first means 100% chance I drew a blue first. Right? Like given, if I say, oh, I drew a card, given it's a heart, that means you know it's a heart. You guys, you know what I'm saying? So given it's blue first means you know what you drew a blue one first. I'm giving you that information. I'm telling you, hey, by the way, I drew a blue one first. Now that you drew a blue one first, what's the probability I draw a green one second? 5 out of 10. It's just 5 out of 10.
Oh, okay. So you don't have to factor.
Everybody good? All right. I would love to go through, if you guys want to stick around, anybody wants to stick around, I would love to go through just one problem, number 15, very quickly, so you guys can remember that, because it's been a little while.
Yeah, let's do it.
All right, so you're free to go if you need to go. It's all good.
Or something from here will be on the test. So that's as much as you.
All right, so you guys work on that for just a couple minutes. This is a test. Everybody has that part, yeah? Is this a mean or a proportion? Proportion. Percentages. 34 out of 210. So, what's my H naught and my H1? P, because it's a proportion.
Yeah.
H naught is always equals. And then this would be P naught is, what's my claim? What's my claim?
12%.
That it is 12%.
Yeah.
Right.
So the H naught and the H1, my claim is always going to be H naught or H1. So that's always going to be where the claim part, the 12%, that's always going to be the numbers that go there.
Okay.
Do you guys understand what I'm saying?
Yeah.
So whatever you figure out your claim, and that's always the number that goes there. Since this is my claim, that means not equal is going to be it's going to be H1. Then the sample one, or the survey one, or the selected one, that's going to be your P hat, or your X bar, right? But your mu naught, or your P naught, is always going to be your claim. Everybody on board? So your mu naught or your P naught is whatever you found in the claim part. That's where the H naught and H1 go. That's your mu naught or your P naught. Okay, so then our step 2 is going to be our critical value. It's going to be a Z or T. Z, because
Yeah.
P, easy peasy.
Yeah, easy peasy.
So you guys going to look it up. Equals, so it's going to be not equal, so it's going to be two-tailed. 5%, negative 1.96, and positive 1.96.
Yeah, 1.96. That's easy peasy.
Yep. Use of freedom don't matter. All right, then next we're going to go to finding out my test stat. So let's see, we've got 34, P hat is equal to 34 out of 210, which is, someone help me,
16.
0.16,
Yeah.
okay? So it means my test stat's going to be, is there one more decimal place? 16 what?
Yeah, there's like one more too.
162?
Yeah.
Yeah, give me at least three decimal places on these guys. Don't round it to 2. 3 sig figs. So it's going to be 0.162 minus 0.12 divided by square root of 0.12 times 0.88 over n. What's my n? 210? Okay, so what do you guys get for that?
What was that? 6.
These scheduled evening after this problem, so you can reclaim your seats.
No, you have to do the top part and the bottom part. Are we looking for?
Yeah, I know, dude. Like, yeah.
I got 1.873.
Yeah, that sounds about right.
Are we gonna reject H naught or not reject H naught?
Not reject.
Not reject H
Yeah.
naught. There's
Do
no
not
net
reject
evidence
H naught.
to proclaim that 20% of students make 808 classes. Good job.
Right, so there's gonna be not enough evidence to reject claim.
Yep.
My claim was
That they were not equal to.
that they were equal to.
Oh wait, yeah, that they were equal to the students.
Okay.
I remember that part.
You had a lot of studying to
To
do.
reject claim
Yeah.
Yeah.
that
Oh.
12%.
She's
Yeah.
just sick. Like a cheat sheet.
Thanks for all.
Or crazy or like a.
Like in classes, yeah, or
I
crazy.
did.
Now, it sure looks like, so not enough evidence to reject my claim, not support my claim, because my claim is, looks like my claim is probably wrong.
Yeah.
I mean, it looks like, 16% is kind of far over, but I sort of have enough evidence to reject it.
Yeah.
My claim is probably not correct. I would need to take a little larger sample so I can reject it. All right, good deal. I will see some of you guys later. If you guys worked in the beginning, then start in with the middle parts of number 6. We're going to do 6B and C because we didn't do those.